So next discussion is the condition of resonance when inductor coil and capacitor and resistor all are connected in series, then we get phase relation between the voltages and the current through the circuit, right? So from the vector diagram, as we have observed, the VC, that is VC is along negative y direction, and VL is along positive y direction, and VR is along x direction, positive x directions. Okay. So here current and voltage through the resistor are in the same direction because there is no phase difference between current and voltage VR. Okay. So finally, we got VL minus VC. This is the resultant of VL and VC because VL is this much amount and VC is this much amount. After subtraction, VL minus VC will give this portion. Okay. So finally, to get the resultant voltage, what we have done? We have drawn a rectangle, and the diagonal will give the resultant between VL VC and VL minus VC and VR. Okay. So that resultant V is obtained as resultant V is obtained from the Pythagoras theorem applying this right angle triangle. So root over VL minus VC whole square plus I R square, because this amount is R square. So since from this right angle triangle OE square is equal EA square plus OA square. So OE is equal to root over EA square plus OA square. So OE is what? OE is V. Okay, V. So V. So root over EA. EA is nothing but this amount. So VL minus VC represents EA. So EA is VL minus VC. So R is what? OA is nothing but VR. Sorry, it is VR, not R. VR. So we are representing only voltage, right? So according to Pythagoras theorem. Now, if we put the values here, that is, if we put the values, suppose here the resistance is I. According to Ohm's law, if I put in place of V as IZ, so Z is the impedance, right? And in place of VL, XLI, okay? In place of VC, XCI, according to Ohm's law, whole square, right? So plus IR whole square, right? In place of VR, I can write IR whole square. IR whole square. So IZ is equal. So I will be taken common. It will come out. So within the root over sign, XL minus XC whole square plus R whole square, right? So II will be cancelled. So Z is the net impedance. Okay. R square. So this Z is called net impedance. Z is what? Net impedance. Net impedance in the circuit. A series circuit to গোটেইটা মিলি পলাই যেটো ইম্পিডেন্স মানে যেটো অপজিশন কৰিব গোটেইটা মিলি যেটো কৰিব হেতুক আমি ইম্পিডেন্স বুলি কৈছো ৰেজিস্ট্যান্স বুলি নাই কোৱা ঠিক আছে সো Z is the net impedance in the circuit গোটেই সার্কিটত Z এ বুজাবো যে ইম্পিডেন্স টু কি তার রিলেশন টু এটো so this expression equation number 1 will give you the net impedance in the circuit. So we also calculated the phase difference between V and I. Phase difference to me draw korisu. So phase difference is given as tan phi. Tan phi is what? Perpendicular by base. This is perpendicular. So perpendicular is nothing but VL minus VC. VL minus VC. Base is what? Base is this. Okay, VR. So VR is the base. VR is the base. Okay. So as I discussed that VL is greater than, when VL is greater than VC, then this phi will be positive. So phi is the tan inverse VL minus VC VR. Okay. So phi is the phase difference between net voltage V and current. So net voltage V. So this is the net voltage in the circuit. Net voltage develop V. So heter mazat phase difference to phi bujabo. ঠিক আছে? So phi a kita value upor depend kore. A voltage kita upor depend kore. A voltage kita যেতিয়া যে সমান হয় তেতিয়ালে 0 হ'ব। So net voltage to net phase difference 0 হ'ব, phase difference নাথাকিব। Okay? Right? So from this expression, what we observe that there is no phase difference when VL becomes VC. Okay? When VL becomes VC, there is no phase difference. There will be some questions when in the circuit there is no phase difference, when the phase difference between the voltage and current will be 0. When, at what condition? This may, you get some short questions. Very simple, but you should have some conception to get answers when you are asked. So you should note on all those things so that you can give immediate answer. So these are the conceptions. Okay. So next point is that how to get the resonance condition. To get resonance condition, condition of resonance. Our discussion is that condition of resonance. How to get resonance? What is resonance? That is not one thing. So in case of resonance, you see the impedance Z. Here V is equal IZ. We are writing what? V is equal IZ. So resonance condition. Here V is equal IZ, right? So Z is equal what? Z is equal V by I. Okay. So Z is the net impedance in the circuit. So it is related with voltage, net voltage, and net current as by this relation. Okay. To get maximum current in the circuit, in the circuit, Z should be minimum. Impedance jitu badha, hey impedance to kom hole a circuit basic current hobo. Okay. A circuit basic current pabole hole, highest current pabole hole, impedance kom hobo, right? The condition is that. So let me rub this. To get maximum current, Z should be minimum. Okay. Minimum. For minimum Z to attack কম হবলৈ হলে আমি কি করব? So এটা উপায় আছে এই পার্টটুক আমি নাইকিয়া কৰি দিব লাগিব এই পার্টটো যদি নাইকিয়া হয় z টু মিনিমাম ইম্পিডেন্স মিনিমাম হলে কারেন্ট টু ম্যাক্সিমাম সো z যদি মিনিমাম হবলৈ হয় এই পার্টটো যদি নাইকিয়া কৰিবলৈ হয় তেতিয়ালে xl should be equal to xc only thing is that xl should be equal to xc এইটো যদি ইকুয়াল হয় যায় এইটো পার্ট 0 হৈ যাব নহয় জানো so this is the condition the xl for minimum z xl should be equal to xc right inductive reactance should be equal to capacitive reactance this is another important point to get resonance condition okay current বেশি হলে আমি resonance condition পাম so if we put the values omega l xl is equal to omega l xc is equal to 1 by c omega remember so from this what we get omega square is equal 1 by lc so as we get 1 by root over lc right so since we know that omega is nothing but twice pi f or nu sometimes in some textbook you write some textbook it is written as nu twice pi f so twice pi f is equal 1 by root over lc okay. So f is equal then f is equal what 1 by twice pi root over lc f is called resonant frequency what is f this f is called resonant frequency okay so in this case f is called resonant frequency and this condition is called resonant condition okay this condition is called resonant condition so you should remember that in this case when it happens then the frequency this frequency of the circuit is equal to the natural frequency that is applied frequency okay যেটো frequency apply কৰা হৈছে সেই frequency লগত এই frequency টো এটো সার্কিটৰ frequency টো সমান হৈ যাব সমান হৈ গলে আমি resonant condition টো পাম so this is all about I think about resonant condition or series resonance circuit similarly we will get parallel resonance circuit also this is series resonance circuit okay so in this case the current the applied current and when the maximum current okay when maximum current is applied is obtained we will get this type of graphical representation resonant condition maximum current becomes maximum this is applied current and current becomes maximum in the resonance circuit যেতিয়া এই কন্ডিশনটো এপ্লাই হ'ব তেতিয়া হলে যেটো কারেন্ট আমি এপ্লাই কৰিছিলো this is applied current এটো হল ইয়াৰ resonant conditionত হোৱা কারেন্ট ঠিক আছে আমি ম্যাক্সিমাম কারেন্ট পাবো পাৰো কারেন্টটো বাঢ়ি যাব so your problem is the oscillating circuit of a radio station has an inductance of 5 into 10 to the power minus 6 that is given L is equal to 5 into 10 to the power minus 6 Henry and what are the other conditions given and capacitance of 0.01 microfarad C is 0.01 microfarad should be converted into farad as 1 into 10 to the power minus 6 farad okay and you are asked to find out the frequency so what will be the frequency by relation is twice pi root over LC so you have to put all the values okay 2 into 3.14 root over L is 5 into 10 to the power minus 6 into 10 to the power 0.01 into 10 to the power minus 6. Okay. After calculating this, you will get some value. That value is 72 into 10 to the power 4 hertz. After calculation, 72 into 10 to the power 4 hertz, because it is frequency. So my interest is to only to show you how to use, if this type of question comes, then how to solve the problem. So L is given. This is oscillating circuit. Oscillating circuit means it should consist of inductor coil as well as capacitor and also resistance. But in the question, you are asked to neglect the effect of resistance. There is no resistance. Only L and C are there. Okay. So this is the frequency from the relation. So putting the values here. The next question is to find out the wavelength. How you will find out wavelength? Because this is a radio frequency. This is radio wave. Radio waves moves with a velocity of light. So you have to find out next problem. V, as you know, V is equal nu lambda. So nu is what? Frequency. V is equal to C here. Frequency is F here, lambda. So you are asked to find out lambda. So C by F. So how you will find out C by F? C is equal to 3 into 10 to the power 8 meter per second. Okay. So F is equal to 72 into 10 to the power 4. Right? Okay. So 3 by 72 into 10 to the power 4. This is hertz. Okay. So 3 by 72, ultimately 417 meter. 417 meter. You'll get the answer like this. After calculation, you will get the answer like this. Okay. So I think you will be able to do this.